Hello, and welcome to today's Environment and Energy Leader webinar titled Innovative Approach to Converting Dairy Manure to RNG, a case study in making ultra-low carbon intensity vehicle fuel, sponsored by Montrose Environmental. My name is Jessica Hunt, and I'm the Director of Live Events for E&E Leader. Before I hand the presentation over to our speaker, I do want to go over a few housekeeping items with attendees. Hopefully I can get through my quick intro as well as the Q&A later in today's event without either of my dogs barking. First and foremost, thank you for being with us wherever you are in the world today. In case you are unable to join us live, this event will be available on demand by this evening. If you happen to have any technical issues at all during the event, please troubleshoot first using the help widget at the bottom of your console. And in case you need additional assistance, please send a message to me via the Q&A widget. Attendees do have the ability to chat with each other during the event as well. To utilize the attendee chat feature, you may have to double-click on Enter Your Message. And we are having a Q&A session at the end of the event, so please submit questions for our presenter during the next 30 to 40 minutes. If we do not get a chance to answer your question during the live event, the speaker or a member of his team will follow up with you as soon as possible. And enough from me. I am pleased to welcome Jacob Stern, VP of RNG Product Delivery at Montrose. And at this point, I'm going to hand the presentation over to him, and I will rejoin everybody for the Q&A. Thank you so much for being here, Jacob.
Thank you, Jess. Can you hear me okay?
We are good.
Awesome. Thank you. Well, good afternoon or late morning to everybody on the call. I wanted to say thank you for the opportunity to present this information and talk about Montrose and our RNG team. As just mentioned, the title of this presentation is Innovative Approaches to Converting Dairy Manure to Renewable Natural Gas. And we'll talk a little bit about what these processes are, what Montrose is doing in this space, as well as specific application of our facility that we built and are operating in Arizona. Hopefully wrap up, as just mentioned, with any questions or comments about the technology or our processes, and look forward to the conversation. Look forward to answering any questions you might have. So thank you again. The picture you see here of these cows, these are cows that live in a dairy in Arizona, the Paloma Dairy outside of Gila Bend, Arizona. Montrose, in a greater picture, does a number of things, but ultimately our vision here is to improve the air we breathe, the water we drink, and the soil that feeds us. And so, not sure if you're all familiar with Montrose or not in great detail, but we have a number of engineering professional services and capabilities around environmental compliance, regulatory and compliance guidance and environmental solutions. We also have emergency response, monitoring, testing, LDAR programs, and the team that I'm a part of is known as Montrose Water and Sustainability Services. We focus on engineering, procuring, constructing solutions, mostly for forever chemicals, specifically PFAS related chemicals, emerging contaminants, and as well as, in this case, renewable natural gas. And so if you ask yourself, what is a renewable natural gas, we're going to hit on that here. Any other questions on Montrose, I can answer as well. Specifically, the RNG Solutions Group, which I lead, is focused on three main capabilities. We provide technical and development advisory solutions. So if someone has a large organic waste stream that they want to convert into energy capabilities and advisory and solutions for those types of streams into energy solutions. We also have a fully integrated EPC organization with offices across the U.S., primarily focused on offices in San Diego, Portland, Oregon, Portland, Maine, Minneapolis, and a number of other satellite offices across the U.S. and a remote team. We also provide operations services and maintenance solutions to the facilities we've designed. But ultimately, our goal here in this space is to basically originate, design, develop, build, and operate fully integrated dairy manure to RNG facilities. We're going to talk about that more here in just a few minutes. This industry has a history of anaerobic digestion and other connected capabilities. We want to be the supplier of choice for anybody looking to install one of these solutions. First name we want to hear is Montrose. We want Montrose to be the go-to. And ultimately, how we're going to do that is flexibility, being urgent and collaborative. None of these projects look the same. They all require special considerations for layout, for technical solutions, for relationships with the different individuals. It's a complex and diverse environment that we're working in, and we want to be able to put renewable natural gas into the pipe or into a vehicle. So that being said, if you Google search renewable natural gas, you get millions of hits. But ultimately, what a renewable natural gas is, and in Europe, it's also known as biomethane. It's methane produced naturally from the decomposition of organic material. So if you think about landfills, organic waste streams, all of those things have bacteria in it that naturally occur that convert volatile solids or other organic matters into natural gas, which is a very basic fundamental molecule, CH4, and it can be used for a number of different things, as shown in this graph here on the right. It's used in existing infrastructure, so renewable natural gas and most of these solutions go straight into pipelines or into other combustion units for heating, electricity, or other industrial uses. And ultimately, if you think about the capability or what renewable natural gas is this natural gas, in the example of a dairy manure facility, typically goes through some sort of treatment process, but ultimately that material is broken down organically, naturally, and methane is released into the environment. So fundamentally, what these projects do is capture that methane through an anaerobic digestion process, and then convert it to usable natural gas. Natural gas in general, when combusted, has much fewer constituents or contaminants other than methane. It burns fairly cleanly, including nitrous oxide and another chemicals. But ultimately, it's a great replacement for diesel or gasoline and vehicle fuels. And the methane that's combusted also reduces greenhouse gas emissions on a net basis, as opposed to going into the environment. Its conversion into carbon dioxide is 25 times less potential as it relates to the impacts of greenhouse gas. So what that means is this material is actually carbon negative energy, as opposed to some low carbon solutions such as hydrogen from electrolysis. Wind power or solar power does require some net carbon inputs to produce. This actually reduces the overall emissions. Montrose's team in general is a very focused team. This is the RNG team is what we do. This is a project. So Alina Cole, who's pictured here, is our senior process engineer, degree highly educated engineer, works in our Minneapolis office. Here she's inspecting some of our equipment that focuses on the transfer of manure into the tank process. So a little more specific to the project here, you can see in Arizona, and we'll talk about the components of each of these processes and what they do. So these projects are fairly quick. From the time we start breaking ground and start engineering into running the facility at the optimal efficiency is relatively quick for the size of the project. Ultimately, where we came in and developed the solution you see here, the farm had specific manure handling techniques that flushed manure into settling lagoons, and this process basically reduced heavily their emissions, their water demands, and they land apply the water from this process as well. So very not only producing great energy, but also reduces water treatment costs as well. And Montrose provided this solution, so engineering, procurement, construction management, commissioning, startup, from around 7,800 cows. And I believe this offsets about 10,000 vehicles on gasoline every year at its capacity. So here's the overall process. We have a vacuum system that collects manure from the facility. It's then transferred into receiving pit and pumped into 3 digesters. These digesters are stainless steel on concrete foundations. They have an interior membrane for the production of gas, biogas, into a vapor space, and the digestate, or the material that's not converted, is then pressed, and like I mentioned, the water is then sent to a covered lagoon for land application. The solids are actually recovered and reused as bedding in the dairy, so it reduces bedding costs, and you have a nice circular bedding solution. So it's very critical in these projects that we interact with the dairy and understand their immediate bedding needs, as well as their manure handling processes and water. So this process in general circularizes a number of activities on the dairy as well. From the digesters, the biogas, and biogas is methane, and a number of constituents, is then treated into our what we call gas upgrading system, and I'll show you the details of the system. Ultimately, you have a number of separation steps, so water, H2S, compression, and then treatment through a membrane system to remove any carbon dioxide, and then to a final compressor, and ultimately into the pipeline and Southwest gas. So, the gas that comes off this facility is no different than the gas that comes off of the gas into your house if you have a gas heating system, and that's the process here. Ultimately, there's specific designs components to this which optimize gas yield relative to the energy input, and that's the most critical portion of this, is total yield of gas for energy consumed, which really drives what we call the carbon intensity of the facility. Again, so these are the digesters. So Montrose, in this particular case, specified these. You see mixing here with the membrane system. This is an outer membrane cover that's maintained under pressure relative to the location of the lagoon, or relative to the location of the dairy. You see it's right next to it. And these are bolted steel tanks, epoxy lined on the inside with mixing and overall gas management components. A really great thing about this process is the ability to normalize operations across long periods of time. So this lagoon acts as 2 major components. One, it produces additional gas from the water, volatile solids in the water that are soluble. It produces additional gas. It also helps treat the water anaerobically into water that can be emitted, and it also discharged, and it also allows for buffering of gas upgrading. So the slower reactions on the front end of the process and digestion go into this lagoon. That's a HDPE cover that'll billow in the wind, not billow, but it'll elevate in the wind, and feeding into gas upgrading allows for very steady operation, very limited downtime, and no flaring. So if there's any upset on either side of the process, this lagoon acts as a buffer. And that's one of the innovative solutions that we've applied here, is this model. We expect to see more of these through the applications of dairy manure to RNG or other RNG solutions. Allows us to be very tightly controlled on composition of the material. Process control and economics are very valuable here. So this was a constructed lagoon. It's about 20 feet deep in the middle, and we placed the cover over it with all the components associated with piping, electrical mixing, and overall management, and it stays nice and cool in the Arizona sun. Dewatering. So this is the digestate, so the material that is not digestible, what comes out of the bottom of the continuous tanks, is then transferred to these screw press separators. The water management is handled, as I mentioned, and the fiber, the stuff that's collected with the manure, whether it's been with the cow or without the cow, is put through these separators. The water is pressed out and recovered, and the solid bedding material is then reverted back into the dairy for bedding. It's a great circular solids handling process, and it's designed to accommodate any number of flow rates and dynamic pressures incoming. The gas upgrading skid. Just as a reminder, what you can see here is all been engineered by Montrose. A number of components are fabricated off-site, and there's sub-suppliers. But from the right to the left, the H2S in the gas typically comes from the water, sulfur in the water, or in the feed into the cow, is removed through carbon media. Then you remove any remaining water from the process before introduction into a membrane system. There are a number of different gas upgrading technologies that separate CO2 and methane in this process. We prefer the membrane system, which allows for fewer moving parts, greater recovery of methane relative to alternatives, and less methane slip into the waste stream that's flared. And then ultimately you have final compression and analytical services and support integration with the local utility. And so compression and blowers and all the dynamics around energy recovery are integrated here. So it's a very efficient, very well-maintained process. So again, Montrose developed the overall heat material balances, process diagrams, controls. So all of the integrated controls is operated by one person during the day, and integration of all the systems and components. So probably the most complex thing about these projects is all the different unit operations that have to come together in an integrated manner. There's been a lot of projects that have not been successful due to integration challenges. We also managed all of the supply chain and procurement management components. So this project was effectively done during the pandemic, which as everyone knows, aside from Suez, the canal blocking in the Middle East, there's a number of challenges in existing procurement and supply chain that were all managed and delivered by Montrose on time. And then overall construction management, quality control, typical delivery processes there, and then the overall introduction of manure, production of gas, and performance testing. And Montrose provided an overall plant performance guarantee, which included yield, recovery, quality, and capacity for this facility. And really where we continue to focus is just overall integration of design and components, conventional operations and optimization allows for efficiency in design. And the conventional techniques on generating biogas, combining them in a certain fashion and control, allows us to really maximize yield in this particular case, which is essential for operation. And then there's other components related to the digester and oxygen management, which is critical for H2S handling and operational costs that are considered. So overall, the facility has great yield and uptime. So that's really the case study here. Speaking to opportunities within applications, I see a number of questions coming in here. I want to be respectful of those questions. Again, I'm pretty quick to speak to these things. So I guess, Jess, one of the questions I had is, do we want to let people ask questions directly, or are they allowed, just want me to read off these You want me to answer the questions that I see here?
Thank you for that part of your presentation. I really do want to say I appreciate all of the attendees who have submitted questions and keep submitting questions. We can do this anyway. I'm happy to ask you the questions. If you want to just take the lead and go ahead and see which ones you want to answer first, be my guest.
Okay, yeah, that'd be great. And there's a lot of great questions here. There were two that came in before. First one here is refrigerant compliance. So there's very limited refrigerant required for this facility. The commercial air conditioning units that are used to condition the gas flow are compliant with standard commercial applications. So no special fluorides or chlorides of any kind into the refrigerant compliance. The next one is, can you recommend ESG certifications you think are valuable? I'm not sure exactly in context, Jess. Did that come from an attendee, that question?
It did. It came from an attendee who submitted it before today's event. So attendee, if you are on, if you could clarify that, we will be happy to answer it.
Okay. And John asked a question and says, do you know the composition of what you're flaring? Yes. So the flaring material, so very rarely do you flare in this facility. Flaring is for pressure upsets. The way the lagoon is designed and integrated with a gas upgrading system, flaring is very rarely occurred. If we do flare, we flare biogas, and biogas being methane and CO2. The only thing that's continuously emitted, and this is obviously a permitted emission with the state of Arizona, Department of Air Quality, is the slip from the membrane system. And speaking to that, it's a fairly low concentration of methane. It's mostly CO2. It's combusted into its major components. We remove all the sulfides. So sulfur is the other major component. When I say major, I mean very minor percentage of the overall composition. There's effectively no sulfur in the membrane system, and so it's mostly just CO2 that's being flared. In some cases, in more advanced applications or larger scale, that CO2 is sometimes captured and liquefied and used for other industries as well. So very, very few emissions from this, and then flaring, like I mentioned, is some components. Let's see. Yeah, it's in the technical concentration. Methane concentration, Ed asked the question, what's the methane concentration at the inlet of the thermal oxidizer? It's typically dependent on the concentration of oxygen in the gas, typically less than 3 to 4% methane. Those are typically the performance specs of the facility. Let me see here. Ed asked another question. How many Montrose RNG projects on farms versus landfill? So Montrose actually does landfill gas collection as well. We have a group, our Portland, Oregon group, led by Dan Wainio, been in the industry for a long time. So we do both dairy farms and landfill gas projects. And so the back end of these facilities do have some slight differences depending on composition in this specific solution. Pretty straightforward technical solution, but we do dairy farms and landfills as well. In total, our experience, whether it's EPC work or consulting, is fairly long. We've been in this business for a long time. Individuals have been working on these projects for many, many years. We work on many projects a year. Another question from Ed. With all the fiber, does the press require more polymer than other dewatering applications? So there's no polymers added to the dewatering system. It's a pretty straightforward water solid separation system maintained on a head pressure. There's this header above here, and no polymerization is added. So a very few additives here. The only additive that we maintain is oxygen for hydrogen sulfide control. And I'll answer the economic-driven questions. Ed, lots of questions from Ed. Thank you, Ed. Equipment lifetime expectancy for membrane separators. You know, the mechanical components of the membrane system will last a long time. The design expectancy of this facility is very long. I would have to find out exactly how long the membranes last. As long as they're not exposed to any particular contaminants, I believe they last for a very long time. So it's not even included in operational estimates for membrane separation systems. And speaking to that, just overall options on the amine systems or pressure swing absorption systems, those do have media requirements that are a little more complex in operation. Oxygen. So as I mentioned, oxygen is injected into the headspace of the 3 digesters, as well as the entry into the gas upgrading system. It's delivered by liquid oxygen systems from a local supplier. Very, very little amount relative to the raw gas flow. Oh man, there's lots of questions.
Yes, that's an understatement. There are a ton of questions here, and we appreciate everyone.
Okay. Yeah. And I'm available, so I think you guys are going to get a presentation of this material afterwards, emailed. Please reach out. We can have one-on-one conversations on these. We're really excited about this industry. We're growing rapidly, and so any opportunities we can get to support folks in this space, we do feel it's our core mission to help deliver these solutions well. And so happy to answer these questions. Let me make sure I answer any more technical questions. Raphael asked, do you liquefy CO2? If there's a economic justification for that as a value stream, we can install a CO2 liquefaction system. That's typically a package unit, but there has to be a demand for the product. Otherwise, it's simpler, and the owner of the facility would prefer to just emit it. We can permit it as such. What is the H2S level? And that was question 20. John Deneen asks, what is the level of H2S that comes out of the digester? So the concentration of H2S depends, like I mentioned, heavily on the water, the sulfur and the water content, the sulfur content in the water, as well as the feedstock. We control to a level that's optimal for the separation step in the membrane system, as well as the performance of the carbon media. There are alternative H2S removal systems, and our gas upgrading system prefers a content. So these H2S vessels here on the right, they prefer a range of, for life cycle costs, a range of anywhere from 1,000 to 4,000 to 5,000 ppm, and basically exit at 0 ppm from the facility, from the vessels, excuse me. Next question from Winston. Were you able to secure feedstock, and for how long? So Montrose does not participate here in feedstock agreements or offtake agreements. We provided EPC services. Feedstock and offtake agreements are a complex dynamic in this industry. Ultimately, that's not part of our business. I can't answer that one. Another question from Raphael, sorry, regarding CO2. So yes, so CO2 emissions are incorporated into the carbon intensity score, which carbon intensity is the direct economic driver for the projects. So the question of, do we capture CO2 and value of credit, it would absolutely play into the value of the project if there was an economic justification for it. Yes, some people do value it. I've seen many CO2 liquefaction systems in Europe where they definitely want to maintain as reduced CO2 emissions as possible from these types of facilities. And I'd also add, we've looked at alternative power. So the full picture here on a system like this is the energy intensity of the power that's provided to these systems is also a key driver. And so we've looked at solar Solar installations for powering as well. Obviously, that's intermittent, which has to be designed. What is the CH4? Question from Dave. What is the methane percentage received? So coming out of the digesters, they're typically anywhere from 55 to 65% methane. And then entering into the unit gas upgrading system, it's then converted into gas spec methane, which is typically above, in the US, typically above 97, 98, 99% methane, high heating value methane. Methane recovery from Pavel, great question. Yes, typically methane recovery, so entering into the gas upgrading system versus the pipe is in that number you mentioned, typically 99%, sometimes plus, sometimes minus. It heavily depends on the membrane system in this application, whether it's a 2-stage or 3-stage system, and the capital economics to justify recovery come from the overall yield and capacity of the facility relative to additional steps. Next question from Ed. Has Montrose been involved with RNG at ethanol plants? We have a number of folks that have participated in ethanol projects in the past. We've looked at organic waste streams from ethanol facilities and many other types of industrial facilities, but there are, at this point, no Montrose installations at ethanol facilities. All right, let me go down to the bottom of the list again here. We'll answer all the commercial questions. I see a couple questions regarding minimum size in the dairy herd. So this is probably what we spend the most time internally in our technical solutions group talking about is minimum dairy herds. So there are better people to talk about this than me. I'm more on the delivery side, making the projects happen. Bernie Sheff, who's chairman of the American Biogas Council, is on our team. He'd be able to answer this question about 10 different ways if he heard this one. So what I can say to minimum head size requirements. So if we look at this dairy, and I said roughly 7,800 equivalents. The dynamics around, there's a couple things that make a huge difference here is existing manure handling practices and dairy operations drive the carbon intensity measurements and overall capital. So whether a site needs additional capital to improve systems, existing systems, or specialized systems for treatment on the back end, drive the projects here. If you look publicly at what's been announced on large projects, we're seeing this size and above is very popular, and the dependence on a viability also depends on a lot of financial things that we're not necessarily involved with, whether it's debt or guaranteed return rates over time. But ultimately, Montrose is focused on doing these projects well, which is going to be the biggest driver for more opportunities in the future. Another question from Ed on economics of biogas combined heat power more profitable than biogas to renewable natural gas. And so this question here on use of combusting biogas for heat or power versus conversion to RNG is primarily driven off of renewable energy credits, both federal and state-driven programs, and that's the big driver right here. So we see a lot of conversion of CHP systems into gas upgrading systems for use in vehicle fuels and pipeline natural gas. Profitability depends mostly on the value of those credits. Question from Tiffany. How long does it take? So we mostly quantify, so the question here is, how long does it take to make an amount of renewable natural gas if you need to fuel residential, family home, or any sort of unit? So the main energy conversion unit here is to gallons of gasoline equivalent. And so a facility like this produces about the equivalent of 10,000 cars per year worth of gasoline. And so you'll see industry or commercial applications of renewable natural gas vehicles that, in the case of actually in 2022, the renewable natural gas demand, the natural gas demand for vehicle fuel in California was actually completely supplied by renewable natural gas. And yeah, I'm sure people have seen headlines that say 100% of the power consumed in California recently has been for the renewable sources. This is a major driver to that component. Another question from Tiffany: what is the price difference for renewable natural gas versus natural gas? So the price difference is mostly driven off of the credits assigned, and we have folks that can better describe the crediting system there. That's question number 11. And again, it's the price difference is again driven off of the market for purchasing credits, renewable natural gas credits. So this solution qualifies for D3 RIN and also carbon credits under the California Low Carbon Fuel Standard. Raphael asked the question: what for Montrose the criteria of a farm to offer the solution? We visit a lot of farms, travel a lot. We see a lot of different farms across the U.S. Criteria is someone that wants to install a great solution. This team here in Arizona, they have a very strong passion. The dairy has and continues to have a very strong passion for a solution here, and it's driven off of a want to. And so if we see a good developer or a good dairy that wants to do something well here, we're happy to jump in. But we'll go anywhere and everywhere for making renewable natural gas. Ed asked another question. Yeah, am I doing okay?
Sorry, I was just saying, this is a fantastic discussion that we're having right now. I just wanted to piggyback on that question. Piggyback on your answer, if a dairy farm is ready to go and you go and do a site visit, what are some of the biggest obstacles that you have to work through in order to get this up and running?
So typically, there's a couple things that we look at really early. Existing dairy operations. Does the feedstock and manure quantities can be measured based on head count, pretty straightforward. You get into the dairy management practices that have to be carefully considered. One of the bigger challenges with certain bedding applications is sand, and the management of sand and separation of sand from digesters is a big challenge. And so there are technical solutions for that, but they typically drive up capital costs to separate sand prior to introduction into the system. And then you end up with more energy required, as that requires water to separate. And the key thing here is getting these digesters as close geographically and temporally to time and space into the digesters. So you want as little manure time other than from the cow into the digester as quick as possible. And so collection processes become very important. How you collect manure from the system, scraping or vacuuming manure versus flushing also makes a big difference. And so when we visit a dairy, that's kind of the key things that we look at is collection processes and bedding processes, because that will basically set forward the first half of the facility and drive capital.
Thank you for answering my question.
Yeah, awesome. This is an exciting place to exciting industry to be in. We see a lot of different applications and opportunities for all sorts of organic waste. So specifically, the reason why dairy manure is a big driver here is because of those collection practices and the amount of methane. So a dairy cow consumes a lot of food and produces a lot of milk. Obviously that's the main value stream out of a dairy farm is the production of milk. So maximization of milk production typically results in a byproduct of a lot of manure. And so that volume of manure and the collection processes that are available in dairies is what's driving the industry right now. And Ed asked another question. I think Ed asked about 10 questions. Thank you, Ed. Great questions. The question here is total CapEx per cow. There's a lot of different metrics on how we look at cow, whether that's cow equivalents. Not all cows are the same, and it also depends on, like I mentioned, the collection processes. So we have a number of metrics there, but it depends mostly on the type of setup and system for capital cost. But typically these projects are looked at as total yield divided by capital cost. Raphael asked another great question. What are the sales cycle between first contract and closing and the payment of the project? Closing and the payment of such project. So typically from feasibility through gas in the pipe, the delivery process for that project takes us about 14 to 15 months. If you include time for financing, time for contract reviews and all that stuff, it does extend, but we are seeing the shortening of time pretty quickly. The major long lead equipments in these projects are the gas upgrading system and the compressors associated with the project. And so we design our delivery solution around both the requirements for financial decisions, so early engineering, preliminary engineering and planning, and then driving into a critical path schedule tool like you would see in any sort of project management book is our focus. The total cycle time is heavily dependent on financial strategies. Once we get the project going, these projects from the time you say start 30% engineering through gas in the pipe is around 14 to 15 months. More questions. Does Montrose verify the RINs produced? Yes. So our capability, again, great question, Ed. Our capabilities in Montrose support the permitting aspects as well as analytical support here. So we, while there are entities that validate carbon intensity scoring, Alina, who I mentioned earlier, and Pat Hurl, our Director of Engineering, have been in this space for a long time, provide preliminary CI scores, and then we provide all the analytical solutions and technical support to verify carbon intensity scoring, as well as overall yield and performance measurement for the facility. So we provide service long past gas into the pipe. Tiffany asked a question. Is renewable natural gas acceptable in all 50 states? Yeah, so the usage of this product is great because it's easy to put in the existing pipelines and infrastructure for this facility. More than likely, a small component of your natural gas, wherever you're at in the United States, probably has a little renewable natural gas in it. The transmission systems here, the pipeline systems are all interconnected in various different ways. So once the molecule leaves our flow meter, an analytical tool, and goes into the pipe, it can go anywhere that pipeline goes. So the overall infrastructure is actually one of the reasons why we really like renewable natural gas is because there's a home for it right away. Awesome, lots of questions. Dave also asked a question on cycle time. I think that one can be closed. A total footprint of the system from Dave as well. So the footprint is really driven off of a couple things. Obviously, this lagoon here is sized. Retention and gas upgrading is the biggest component of the space, and then the digesters are as well. So relative size here. This is about, I believe, I want to say it's about a football field wide and about 3 football fields long. These tanks are about 100 feet long each, and the overall gas upgrading system is fairly small. So geographically, the layouts of these facilities fit within, a few acres, and can be optimized within the dairy operations as well. So luckily, these dairies are not in a usually metropolitan areas, and so there's space to work with and the dynamics around their existing operations are considered in the development of the project. Winston asked the question, do you have an estimated O&M cost on the digester per energy produced? Yeah, so again, this depends mostly on yields. The major operating costs here are energy for gas upgrading conversion and operating expenses. So typical operation of this unit, operation of this specific unit is one kind of senior level operations lead operator, and then we have three shift operators that also run the facility. All of the preventative maintenance, reliability solutions are provided by those operations groups, so it's very limited operating costs. Other than that, it's media costs and energy costs are the main drivers here. So typically, on an MMBtu basis, again, it depends on capacity and size. And then versus food waste versus landfill gas, I don't necessarily have a good answer on that. I can follow up with you, Winston. I think that's all the questions. Any more?
I was going to say,
any more questions?
Sorry. As we talk over each other, I apologize there. We did Ed
another one. Man, Ed, we need to talk more. Great questions. Is the farm site in Arizona an integrated site where crops for forage or corn and soy are grown adjacent to the dairy farm? Yeah. So that dairy does grow a number of different crops. I can't speak exactly to which ones, but that's what you're continuing to see in dairies, and dairies and farms in general continue to optimize within the industry that they provide. So supply chain inside the dairy is critical. So like we provide water to them, they give us the manure, and the bedding goes back. When I say we give, and I mean just in the transaction of the material moving the site. But this facility, like I mentioned, Paloma Dairy, you can Google and see their full operation out in the space here. So great facility actually, and really happy to have this facility as part of our experience.
Okay, well, we're going to give everyone a couple more minutes to submit any last questions. If you are watching this on demand, please feel free to submit questions for Jacob. He will get back to you, or a member of his team will. So just because you're not joining us live doesn't mean you cannot ask questions. So hopefully we will get some more in, and you will be hearing from Ed because he just sent another message in. But
awesome.
While people are trying to gather their final thoughts, can you give our audience 3 or 4 big takeaways? We covered a lot of information today.
You know, so I joined Montrose last year from a large organization previous to Montrose. What I really love about this industry is the ingenuity and the strategy that comes along with making a complex solution like this happen. If you look in this space over time, it's not easy to do these projects. There's a lot of people that want to do well, and there's a lot of people that are learning. And so where I think this industry will continue to be successful is through collaboration, challenging ourselves, looking for improvement opportunities, and the dynamics around relationships and circular economy of energy has legitimate application here. And so it's definitely an exciting time to be a part of this work. Montrose is a special case of these solutions and engineering teams that focus on these projects. I'll go back to the front here. So if I really talk about why Montrose in the context of these types of projects, is because renewable natural gas actually hits on all 3 of these. The air, the water, and the soil are all impacted by renewable natural gas in these solutions. And so it's a great opportunity. And the overall scale of applications for organic waste into energy in the United States is massive. So if anyone has interest in figuring out how to make this happen, I highly suggest looking at renewable natural gas as a true solution and a practical solution for our future state of energy usage in this country and worldwide. So we just want to continue to do projects well and keep people safe and protect the environment. So that's why we're doing this.
Which is all fantastic. And I can definitely hear the passion in your voice when you talk about RNG and everything that you guys are doing at Montrose. So I think given that we don't have any other questions that have come in, we can conclude today's event. Again, I want to thank all of the attendees for being active participants in the webinar today. Thank you, Jacob, for your presentation and the work you put into today's event, as well as the entire team at Montrose. Just letting attendees know as well that we will be uploading the slide deck to your attendee console, so you will be able to go back in and grab a copy of it at your convenience. And again, thank you, Jacob. It's been a pleasure to work with you today, and we hope everybody has a wonderful rest of the day.
Yeah, thank you, Jess, and thank you for everybody for participating and for all the Montrose folks who cannot be on here but listen to this follow-up. Thank you for all the hard work that you do. It wouldn't be possible to share all these great stories without it. So thank you.
Great way to wrap it up. Have a wonderful afternoon, everyone.